class. That is always today's class, we shall be discussing a topic, prime factorization of numbers. But before we commence, let us solve the previous class exercise. Find all the factors of 8, 42, and 8, 30. We'll take it. Remember we discussed our factors. Number that can divide 42 without remainder. 42. So we'll start from the list. That is 1. 42 divided by 1 will give us 42. 42 divided by 2 will give us 21. 42 divided by 3. 42 divided by 2 will give us 14. 42 divided by 4 cannot go. 42 divided by 5 cannot go. 42 divided by
7. 42 divided by 7 will give us 6. Are you following? Here now, the numbers has repeated. This number now, factors repeated. So no need of going. You've already actualized it. That implies that 1, 2, 3, 6, 7, 14, 21, and 42 are factors of 42. I repeat, factors of 42 are those numbers that when you divide 42 with them, you get a number without remainder. So for you to find the factors of 42, now you start from the list number. 42 divided by 1 will give you 42. Therefore, 1 is a factor of 42. 42 divided by 2 will give you 21. Therefore, this one is among. 42 divided by 3 will give us 14. Therefore, this one is among. 42 divided by 4 cannot go. Therefore, 4 is not a factor of 42. 42 divided by 5 cannot go. Therefore, 5 is not among. 42 divided by 6 will give us 7. Therefore, 6 is among. 42 divided by 7 will give us 6. Therefore, 7 is a factor of 42. Remember what I said. Whenever a number starts repeating, it then means that you've already factored out all the factors of the number. Therefore, you take the ones that divide the number without remainder. That is 1, 2, 3, 6, 7. Then 14, 21, and 42. These are the factors of 42. That is our answer. We'll now take the second times P. That is 30. Let us find the factors of 30. We start. 30 divided by 1 will give us 30. 30 divided by 2 will give us 15. 30 divided by 3 will give us 10. 30 divided by 4 cannot go. 30 divided by 5 will give us 6. 30 divided by 6 will give us 5. Factors has repeated. Factors repeated. Therefore, we have factored out the whole numbers. This implies that 1, 2, 3, 4 is not among, 5, 6, 10, 15, and 30 are factors 30. This is our answer. I repeat. To find the factors of 30, divide any number that can divide 30 without remainder is the factor of 30. 30 can be divided by 1 to give us 30. Therefore, 1 is among the factor. 30 can be divided by 2 to give us 15. Therefore, 2 is among the factors. 30 can be divided by 3 to give us 10. Therefore, 3 is among. 30 cannot be divided by 4. Therefore, 4 is not included. 30 can be divided by 5 to give us 6. Therefore, 5 is among. 30 can be divided by 6 to give us 5. Therefore, 6 is among. Remember that we stopped here because the factor, the number that can divide 30, has repeated. Therefore, we stop. Then, we take it up. 10 can divide 30 to give us 3. Therefore, 10 is among. 15 can divide 30 to give us 2. Therefore, 15 is among. And 30 itself can divide 30 to give us 1. Therefore, 30 is among. These are the factors of 30. So, having solved the exercises, compare it with what you got to see if you get the right answers. If you didn't get it, please pick the corrections. Let us now go to the topic of today, prime factorization of numbers. We'll now go to the topic of today, prime factorization of numbers. But before we commence, let us understand the meaning of prime numbers. A prime number is that number that only 1 and itself can divide without remainder. Are you following? Example. Examples are 1 is not a prime number. The reason is because 1 can divide 1, but there's no other number that can divide without remainder. So 2 is a prime number because 1 can divide 2, and at the same time 2 can divide 2 without remainder. There is no other number on earth that can divide this without 1 and itself without remainder. 3 is a prime number because 1 and 3 can go. 5 is a prime number because 1 and 5 can go. 7 is a prime number. There's this number, 9 is not a prime number. Many people mistaking it to be because there are so many numbers. 1 can divide it, 3 can divide it, and 9 also. Therefore, it's not obeying the law. Therefore, 9 is not a prime number. 11 is a prime number. 13 is a prime number. 15 is not a prime number. 17 is a prime number. And 19. Remember what we discussed about this? Infinity. So, having the knowledge of this now, let us go to prime factorization. Prime factorization of a number simply means a number that you can derive meaning you can derive the number by multiplying 1 or 2 or 3 prime numbers. You understand? let's say prime factorization of, let's take 60 as an example. Prime factorization of 60 now. We can use T diagram to factorize this to get the prime numbers, prime factors. 2 can divide 60 to give us what? 30, right? And at the same time, 2 again can divide 30 to give us 15. I'm using the prime numbers to divide now. I'm not using composite number. Then 2 cannot divide 15 again. So, but another prime factor or prime number can divide it. That is 3. 3 can divide 15 to give us 5. 3 cannot go again. Then another prime number can divide it to 1. That is the end. Therefore, these are the prime numbers that each product, when you multiply them, can give you 60. In that sense, the prime factorization of, this implies that prime factorization of 60 is equal to 2 times 2 times 3 times 5, which will give you 60 as our answer. 2 times 2 is 4. 4 times 2, 4 times 3 is 12. And 12 times 5 is 60. That is the answer. Example 2. Find the prime factorization of 106. Okay, here we go. Solution. Remember what I said. You use T diagram. 106 to find the prime factors. And finding the prime factors, you start with the number, the least number, least prime number, then and move on until you get the prime numbers that when you multiply it, you can be able to achieve what you want to find out. So 2 as a prime number can divide 106 to give us 53. When you check very well, you find out that there is no other prime number that can divide 53 without remainder. Therefore, since 53 is also a prime number, 53 can divide 53 by 1. This implies that prime factorization of 106 is equal to 2 multiplied by 53, which is equal to 106 as our answer. You understand? I repeat. To find the prime factorization of 106, we use the T diagram. Our aim is to use all the possible prime numbers here that can divide 106 without remainder. And at the same time, when you multiply those divisors, you can be able to get 106. So we start with the least one, that is 2. When 2 divides 106, we get 53. But there is no other prime number known. that can divide 53 without remainder. Therefore, 53 itself, being a prime number, can divide 53 to give us 1. This implies that prime factorization of 106 is 2 multiplied by 3. That is what we wrote here, which is equal to 106. That's our answer. So I will give an exercise which you will try at home. In the next class, we shall solve it. Please do well to try it at home. Find the prime factorization of A, 80, B, 120. That is that for today's class. In the next class, we shall solve it. But meanwhile, make sure you try it at home. If you're new here, we urge you to subscribe for more updates by clicking the red button. Like, comment, and also share with your loved ones. See you in the next class. God bless you.